So today we'll start with chapter 13, user-defined functions. The previous chapter was about the general explanation about functions and types of functions, and majority of the explanation was about built-in functions, standard library function. But this chapter is about user-defined functions, where you're going to learn the concepts of functions, how to write our own functions and types of functions, so and various things. So let us explore this chapter one by one. So here the definition: user-defined function. It's a function defined by the user to solve his or her problem. Such a function can be called nothing but invoked from anywhere and any number of times in the program. Right. So there are advantages where some set of statements, if they are repetitively occurring in your program, then instead of writing them again and again, so what you can do is you can create the function that saves space, as well as number of the length of the program will be reduced, and execution will be increased. And if a task needed is in more than one program or group of programmers, a function can be developed and made available to other programs or other programmers also. Programs can be modularized into functions, right? Each function can be developed independently, debugged, and tested. If a problem is divided into sub-problems, a team of programmers can be formed to solve each sub-problem, rather solving by a single person, which increases the development time. So the development time will be reduced. In a less time, we can develop more programs. And this is the syntax of function definition, we call, right? Function definition, or we call it as structure of user-defined function. You can see that there are two parts in this. The first part is called as function header, whereas second part is called as body of function. Where in the function header we have, so we are going to see all those things one by one. See, we have return type specifier, function name, argument list with declaration there itself. And after that, opening brace is there and even closing brace. Inside that, whatever you write, it is all body of the function, which contains local variables and the statements, and last return keyword will be there. So let us explore all these things one by one. The return type specifier means it is going to have a data type. It's going to have a data type, like it may be a int or float or character or long integer, right? And more. So here, suppose for example, if I'm writing int add, right, like this, then the return type in this function is int. That means this function is going to return integer type of value, right? That means whoever is invoking this function, no, they should provide one integer variable for receiving the result of this function. So say for example, float area, right? Some parameters are there here. And this function is going to return a value of type float, right? So suppose if I'm writing a keyword void display. So that means this function void keyword, it's a keyword which represents nothing. This function is not going to return any type of value. It is going to make calculation, or it is going to do some work with a statement, but it is not going to return the value to the caller, right? So when void keyword is there, remember the return statement will not be there. If void is not there, then in such case, what happens? Return keyword will be there in these cases, but when void is there, return keyword will not be there. And local variables, these are like temporary variables we use in the function for storing some value. And executable statements are set of statements, right? So set of statements which are returned to achieve the result. For what purpose you wrote this function to achieve that result? What all executable statements are required? It may be printf, scanf, or competition statement, or decision-making statement, branching statements, looping statement, maybe any statement, right? Any number of statements can be written inside the function. And here the function name what we have, this function name should be a valid identifier name. Function name must follow all the rules of identifier, naming a identifier. Arguments are nothing but these are the input values which are required by the function to achieve the results. So what all input values are there? Arguments, variables. You have to declare it inside this bracket. Multiple variables have to be declared by separating them with a comma. If say two integers are there, you can't write int a comma int a. Remember, sorry, here you can't write int a comma b. You can't write like this. You have to write separately int a comma int b. And then suppose if the return specifier, if it is not containing int, float, character, long, something like that, if it is containing a keyword void, then return statement will not be there. If there is no void over here, if some data type keyword is written, then return statement is mandatory, mandatorily written to return the value. That is parts of the function. And here they have written directly to find the greatest of three numbers. This is not good. Here, what I do, see, in the function, what happens is, in this case, there will be a, like first, it will be about three sections will be there in the functions. One is about prototype, function prototype, function calling, and then function definition. Three sections will be there, right? Function prototype means declaration of the function. Function prototype means declaration of the function. Wait, here it is there. I'll change this sequence because this is not proper. Directly, if they give you a program for a function without explaining the parts, it will be difficult for all of you to understand. That's why I'll change the sequence of topics. Now I'll go for function prototype first. Yeah, function prototypes. Function prototype, like whenever we are using any variables, we declare the variables and then we use in our programs. Like say int a, we declare the variables and then we use in the program, right? In the same way, the function has to be declared. The function has to be declared. We can call it as a declaration of function is called as function prototype. So this function prototype, it will be written usually before the main program. And what all it contains is this one, return type specifier, function name, and the arguments ended with the semicolon. So return type specifier or function name, then only type you can assume that there are three integer variables, int a, comma, int b, comma, int c. We write like this in this method. Whereas in the second method, you need not to write the variable name. Just you can write int, comma, int, comma, int. If you write int 3 times, it's enough. You need not to specify any variable there, right? That is function prototype. So we'll have some examples based on this prototype. Say, for example, assume that I want to print my address, right? So what I do, I'll say address, and here it is not returning anything, and it is not taking any arguments, right? But when you are writing void, no, it means nothing. It's not returning anything, and it's not taking any parameters, right? So here, this can also be written as just like this. This is also okay. But it is a systematic way that you have to specify the return specifier and the argument type also. Do you know many of the times when I'm writing the program, I'll be writing main. You know, internally what it is actually? Void main void. Right. Fine. That is prototype. Assume that I want to solve addition of two numbers. The name of the function, I'll give it as add. Okay. And how many input values are there in this A and B? And that I want to take it as integer. So I can write int A, comma, int B. See, two times separately you have to write int A, comma, int B. And the result, no, after adding A and B, the result will come in the integer data type. That is why I have written return type specifier as int. So this can also be written as int add. Instead of writing int A, comma, int B, I can just write int, comma, int in the prototype I'm saying, not in the definition. All right. Assume that I want to solve area of circle 3.142 into R. So what we do, the name of the function is area circle. How many input values are there? Only one variable, int R. And it's going to return the result of type float. So return type is float, and input argument or parameter or input values, what you are supplying to the area circle function is there is only one argument and it is of type int. Okay. Say assume that I am solving average of three numbers. So a plus b plus c whole divided by 3. So in this case, I'll write float average in the bracket int, comma, int, because there are three input values. Hope it is clear. Function prototype. So this is called as function declaration. That means we are going to inform C++ uh, about what kind of value it will return, what function name I'm going to give, how many argument I'm going to write, what type of arguments they are going to be, so that it is required for the cross-checking whenever you are calling the function, when you are writing the definition of the function, whether you have written it as per the declaration of the function or not. If you are not writing, right, then in such case, it will be a mistake, it will be an error, right? It will be saying that function with these type of arguments are not present. So that is what function prototype. And after the function prototype, function calling will come. Right. Here it is, calling a function. See, calling a function means what? You are going to refer. You are going to refer that program function. When you call the function, then only the function comes into the action. It will execute its statements and it will produce the result. Right. If function calling is not done, it is of no use at all. Function calling is very important. So calling function is a function that transfers control from it to another function by specifying the name of that function, and passing arguments. Called function is a function that receives the call and arguments from another function. Calling function. Function call is the statement that is used to call or make another function execute. When function call is made, the control jumps from calling function to the called function. Right. So here, one moment, I'll try to show you one diagram. I'll check it out if it is there. Here you can see a diagram. See here at the left side, I have written definition of a function int add int x comma int y. So here what function I have written, this is the part body of the function where set of statements will be there, which will be doing addition of x and y and returning the result. Here you can see that calling a function is there. When you call the function, so what happens is the control of execution from calling function to the called function. Suppose in the main program, if you are calling the function, it is called as the main program is called as calling function. And main program is calling which function? Add. That add is called as called function. Right. So from the main program, when you call this add function, then the control of execution will transfer to the place where definition of this add function is written. And after executing the set of statements present in it, it will return back to the place from where it had been called before it starts executing with the next statement below this. Right. That is a thing. Again, I'll come back to that diagram later on. This is calling a function, but let us see how to call the function. Suppose, for example, void address is there. If I want to call, you know what I do? I'll just write address. But int add is there, no? There is a return type over there, int add. Before add, there is a int. That means always there must be a receiving variable, some receiving variable of type int only. Just you have to write add. And 2 integer value it requires. So I'm supplying 2 integer value 5 and 6. Right? And suppose the area of circle, the return type is float, no? I'll write float. Say y equal to area circle. In the bracket, you send a value. Float average int comma int comma int. So my receiving variable will be float v of like float only because the name of the function is average. So you can see here int p int q. So you have to supply 3 values to it. Like this. This is calling of an average function. Like this, you can call the function as per the prototype. Right. Prototype is what? It's like a rule. You have to, while calling this function, you have to follow the things present in that. Right. That is calling a function. And after this, so main is also a function. It is also user-defined function only, but the name will be main. You can have int main. If there is int over here, then return 0 here, right? Right. So this is returning a value. Returning a value means what? Here for these functions, you saw that we have a return type. When there is a return type, the function must return the values to the calling function. So that arrangement will be done by return. So that when the function is called, the control of execution shift to the call function. Call function will Called function will do the necessary actions or it will execute some statement. So when that function is called, inside the function definition, whatever return type will be there, no, that return type, return statement will return the value to the calling program. Calling program receives the value and then it is going to use that value into some other formula or just for printing purpose, right? That is what returning the value. Here also they have given example. Right. Now we came to know about prototype calling a function and we have to write the definition. For that, I'll just write one sample program. Directly in the compiler, will execute online C++ compiler. So what I do here, below hash include, I'm going to write prototype. Say void address void semicolon. It's called as what? Prototype. Function prototype. And when you are, and in C++ programs, always there will be a line using namespace std should be there always, so that we can write only cout. Fine. Now, I want to call that function. How do you call? Just by writing address. Now I'm going to write the definition. Definition, we are going to write it outside the main program. So this is called as what? Calling a function. And then this is also called as what? Invoking, calling or invoking. It's called as, both words are same. And here, same as prototype, you have to write the definition. You have to start with this prototype one, but semicolon should not be there. And here what I do, cout /n Habbit2Code, and again W7 sign /n online coding classes. Right now I'll use some. So whenever I call this address, I'm going to get these two lines. Now let us execute, run. See here in the output, Habbit2Code online coding classes. And then this is one program. If you want, you can take a screenshot of this. This is one definition. Now assume that I want to calculate square of a given number. For that, I'll write one prototype, one more prototype. Let it be there, address, no problem. Or for clarity, you can remove this. You can make a fresh. This is function definition. See, the name of the function is square. It requires one input, right? Int, semicolon. And the result, what we are going to get, we are going to get it in int. So here what I do, int answer equal to the name of the function square, and in the bracket you have to pass one integer argument, 5. So that means 5 square will be calculated and the result will come into answer, and that answer you can print it here. Square of a number. Fine. And here we can say answer. This is calling and printing the result. So write the definition. What do you have to do? copy this prototype, then remove the semicolon, and for this int you give one variable p, and then you have to say return p into p. This is called as what definition of the function. See, this is function prototype, function calling, and function definition. 3 parts. Now, when I call this, the 5 square will be printed as 25 directly. So here function will be declared. By this, it will come to know that the name of the function is square. It is taking one integer argument, and it is returning value of type int. So int main square f. That means you are calling the function square here. The control comes to this function. And here in the definition, the return P and Q calculation will be done. The result will go back to the calling function. This is called as called function. From the location from where you are calling, no, that function is called as what? Calling function. So result will go back to the calling function and assign it to answer. Right. So 5 is passed. It goes to this P. Both will be, this P variable will be 2 times multiplied. Result is returned. So return in the sense, the result will go back to the calling place. That means internally this invoking a function or a calling a function will be replaced by the result of P into P. And that result, later on, it will be assigned to the landscape. So it will be assigned to the answer variable, and that answer variable is being printed. If you want, you can print, or you can use it in some other equation. That is also possible, like this. Assume that I want to add 2 numbers. So I say add. I need 2 parameters in command, and after doing addition of 2 numbers, result will come in integer only. That's why return type is int. And here the name of the function is add. In the bracket, I have to pass 2 numbers, 2, 8. And here also I have to change the name of the function. So it is add. Here int p, int q. And remember, don't use semicolon at the end. And here it is p plus q. Fine. So when you execute, result of 8 plus 2, 10 will be displayed. This is the thing. Like this, you can write the functions. Okay. Types of arguments we will see in the next part, second part. Okay. Thank you. Bye everyone. Have a nice day.